One method to solve a quadratic function is by factoring. When we solve these quadratic functions, if we were to graph them, basically what we are finding are the x-intercepts of the graph. So we can tie that in later with graphing. When you solve by factoring, you want to make sure that your quadratic function is in standard form. So here's our x squared plus bx plus c, and it has to be set equal to 0. That's like putting a 0 in place of the y. That's why we're getting these x-intercepts. Once you have everything set equal to 0, then you're just factoring a trinomial. What you want to look for is just look at your x squared term to see if there's a number in front. If there's a number in front, that means you'll be guessing and checking. If not, you can just follow the factoring pattern where we look at this last term, negative 48. We're looking for factors of negative 48 that add up to a negative 2. So if you think of negative 48, what are some factors of negative 48? First ones that come to my mind are 6 and 8. And because it's a negative 48, one of those has to be negative. So can we make one of the 6 or the 8 negative and get them to add up to the negative 2? And if we make the 8 negative, that will work out. So what we do is we go ahead and we factor it. We have x plus 6 and then x minus 8 equals 0. And then we have this thing called the zero product property. Because we are multiplying these two factors together and we're getting 0 as the answer, that means that either the x plus 6 has to equal 0 or the x minus 8 equals 0. Oops, that's a minus. So what we do is we just go ahead and set them both equal to 0. And then we solve for x, so we'll subtract 6. So we have x equals a negative 6, and on this one we'll go ahead and add 8. So x equals a negative 6 and a positive 8. And remember, on a graph, that would be where your two x-intercepts are. But solving by factoring is how we just did that. Alright, our second example, first look to see is it in standard form, which it is, and then look at your leading term, x squared, because there's not a number out front, we don't have to guess and check. So what we're going to do is we're going to look at the last term of 4 and say, what are factors of 4 that add up to a negative 4? So your factors of 4 really are just 1 and 4 and 2 and 2. So which of these could add up to a negative 4? Well, that makes me look at the 2 and the 2. 2 times 2 is 4, but 2 plus 2 is a positive 4, and we need it to be a negative 4. So what we'll look at is what if both of these are negative? Negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4, and if you add those, you get the negative 4. So we will factor this with a negative 2 and a negative 2 equals 0. So we factored it. Now we'll do the solving piece. If you notice, these are the same factors, so if you set them both equal to 0 and solve, you're going to end up with the same answer. So in this case, there's only one answer for x, meaning there's only one x-intercept. So if you add 2, you don't have to do it on both equations. We know that x equals a positive 2. Alright, our last example. First, is it in standard form? No, it's not. You need everything on the same side. If you keep your x squared term positive, that's going to make the factoring a lot easier. So let's go ahead and subtract 3x from both sides. So we have 2x squared minus 3x minus 20 equals 0. Alright, so it's in standard form. Now look at the x squared term. Because there's a number in front of x squared, that means we are going to guess and check. So when you guess and check, you go ahead and set up your sets of parentheses. And the first term that we write down has to multiply to give us 2x squared. Well, we don't really have a lot of options there. Basically, just 2x times x gives us 2x squared. And the second numbers we pick for the second spot have to multiply to give you a negative 20. So your factors of negative 20, well, factors of 20, I mean, there's 1 and 20, 2 and 10, 4 and 5, and you're basically just trying any of these. I I'll try the 4 and the 5 first. Eventually we are trying to get this middle term of negative 3. So let's see. I'll do the, I don't know, maybe minus 5 and plus 4. So we're guessing, we're going to check to see if we got it right. So here's how the check works. To check, you just multiply the outside and the inside terms. So 2x times 4 is 8x, and negative 5 times x is a negative 5x. So does 8x and a negative 5x combine to give you this middle term of negative 3x? Well, 8x and negative 5x is a positive 3x, so it tells me we're close. The only thing that we will have to do, because we need a negative 3x, is change our signs right here. So if we make this, I already forgot what it just was. If we make this a positive 5 and a negative 4, what's going to happen is 2x times negative 4 is a negative 8x, and 5 times x is a positive 5x. And when you combine those, you get negative 3x. Alright, so we have it factored correctly. I'm going to go ahead and just rewrite this over here. We have 2x plus 5, and then x minus 4 equals 0. So it's factored. Now the solving piece is you take each parenthesis and set it equal to 0. Or each factor and set it equal to 0. So on this first one, if you notice there is this 2 in front of the x, that means that you're going to end up with a fraction on this. So we'll go ahead and subtract 5 from both sides. 2x equals negative 5. Then we'll divide by 2. So one of our answers is x equals a negative 5 halves. And then we'll take the other equation and solve for x. And on that one we're going to get a positive 4. So x equals a negative 5 halves and a positive 4. I also have videos on just factoring that are on Moodle in the same section, and so if you need to work on factoring or if that's what your issue is, go ahead and check out those videos also. This video shows the factoring and then taking it a step further to solve for x.